Hello all. So on this particular video, we try to find out the shape function for a higher order element, and what we are looking into is a 9-noded element. So we'll start with the definition of what does this particular terminology, a higher order element, mean. An element can be classified into two categories. One is referred as a lower, and another one, of course, it is the higher order category. So when the elements to take into consideration. For example, this particular rectangular element that we have considered has nodes in the edges, then it is referred as a lower order element. So if we take a triangular element, obviously three edges are present, then it is referred as a lower order element. Whereas a higher order element again has two categories, but just a higher order element, as of now, we'll consider it as nodes not only at the edges but at some other positions also. So this particular category will fall under this higher order element. Similarly, if you want to take a triangular element, so this is a triangular element, a lower category, and if it has other nodes that are present in it, then it falls under the category of the higher order element. So what we are trying to find in this particular video is a 9-noded rectangular element. So we'll have node number 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we'll be having 9 nodes, and we are trying to find out the shape function for this particular element as a whole. So as I stated in the previous videos, there are many ways of finding out the shape function, but what we are trying to do in this particular class is we are trying to follow something that is referred as a natural coordinate system. So a natural coordinate system, as everyone knows, it's very much on the simpler side. All the values, sorry, all the values will have a boundary of just plus or minus 1. So this is the consideration that we are going to take. So this particular 9-noded rectangular element will be following a natural coordinate system. So calculating the shape functions can be done by using the simple Lagrangian method. So we'll try to find out the shape function for the first node. So for the first node, as everyone is clear, we'll go for the n1 shape function of the first node. So we'll go for the multiplication of the shape function of node 1 on the x-axis and the shape function of node 1 on the y-axis. So if we consider the x-axis, node number 1 is present over here, 5 and 2 are present in the x-axis. So what we are going to consider is only the x term that is present in all the cases. So nx1 will be Lagrange's method x minus 0 into x minus 1, and similarly the value of x for the first node that is present over here is minus 1 minus 0, and again here it is minus 1 and minus 1. We can further simplify it, so it will be x into x minus 1, and here you'll have minus 1, here we'll have minus 2, put together it is just 2. Similarly, in y1 also can be found out in the similar fashion, but when you go for the y direction, which is in this particular way, we'll have node number 8 and node number 4. Again, what we are trying to do is just looking only into the y term, which is basically 0 and then 1. So here also, if we do consider, it will be y minus 0, y minus 1. Similarly, the value of y over here is minus 1 minus 0, minus 1 minus 1. Put together, you'll have y into y minus 1 divided by minus 1 into minus 2, or it's just y into y minus 1 divided by 1 into 2, or just 2 as a whole. So this is what we'll be doing over here. So as I stated, we will be looking into the x direction separately and y direction separately. Multiply both these things to find out the shape function of the first node. Lagrange's method, x minus 0, x minus 1, and once you supply all the necessary values, you'll get what is the shape function in the x direction for the first node. Carry out for the second condition also in the y direction for the first node, and once you find out both the answers, just multiply it. So it will be as simple as that. So n1 is equal to x by 4 into 2 into x minus 1 into y minus 1. Basically what you're doing is you're trying to multiply this particular value and the ny1 over here. So as I told, this is the value that you'll be getting for the shape function of the first node. Similarly, you can also get to the other shape functions. We'll again start with the second one, which is easy for us. So again, we are going to consider the second node over here. So you're going to consider both in the x as well as in the y directions. So if x direction is going to be considered, obviously you're going to end up with the value minus 1 over here and 0 over here. So as it is stated, what you're going to get is a simple value x minus 0, which is present over here, and x minus 1, which is present over here. So minus of minus 1 will give you the value of plus 1. Substitute the value of x, which is 1 over here, you'll be getting what is the value of nx2. Similarly, in the y direction, you're prone to have two things, that is 0 over here and 1 over here. So again, you're going to have 0 and 1. Just substitute it. So it is y minus 0 into y minus 1. This is a minus sign that will be present, or this particular value entirely will be different. This is not 1 and 1, it is minus 1 and minus 1. So please make a note of this. It is minus 1 and minus 1, and here the next step is correct, so which will give you a value of minus 2. So and finally, as it is stated above, you can find out what is the value of n2, which is nx2 into ny2. So this is the value of your second shape function. So similar to this, you can try and then find out the shape function for whatever or basically you are going to find out the shape function for all the nodes. So you'll go with node n3. Similarly, node number 3 is present over here. So in the x direction, you're going to have 1 and 1. So here you can find it out. I'm sorry, x direction is 0 and minus 1. So it will be x minus 0, x minus of minus 1, which is x plus 1, and then just substituting the value of 1, you'll be finding out what is nx3. And then the next step is where you're going to find out in the y direction. So basically you're going to have 0 and then minus 1. So it is y minus 0, y minus of minus 1, which is plus 1, and here the value of y is just 1. Substitute it, you'll find out what is the value of ny3, and finally you will find out what is the value of n3. Next is your fourth node. So again in the x direction, you'll be having a value of 1 and again 1. Just a second. I'm sorry, here it is 0 and here it is 1. So you'll be having 0 over here. Sorry for making that particular mistake. So here you'll have 0 and here you'll have 1. Substituting it, you'll be having what is the value of nx4. In the y direction, obviously it is 0 over here and minus 1. So it will be having y minus 0, y minus of minus 1, which is y plus 1. You'll be having what is the value of ny4. So your n4 is nx4 times ny4 you'll be getting what is the value of your fourth node. So similar to this, you can try finding out the other shape functions. Let me just go for the intermediate node which is present over here. So n5 is considered, so you'll be having both the x direction as well as the y direction case. So in the x direction, obviously it is easier. So what we are trying to look is -1 over here, and similarly 1 over here. So your nx5 is x minus of -1, which is x plus 1, and x of -1 divided by the value of x that you have over here is 0. So it is 0 plus 1, and then again it is 0 minus 1. So put together you'll be having a value of x plus 1 into 1 minus x, or you can just change it as 1 plus x into 1 minus x, or it is just 1 minus x square. So this obviously we have seen it in linear algebra. A plus b into a minus b, the value is a square minus b square. So this is what we have done over here. A plus b into a minus b is a square minus b square, right? So this part is done. Next, in the y direction, if you do consider, you have a 0 term over here and a term 1 over here. So what you're going to have is n y5 is y minus 0 into y minus, or let me just write it over here, y minus 1, and the value of y is, for the fifth node, is -1, so it is -1 minus 0, -1 minus 1, or basically it is y into y minus 1 divided by -1 into -2, or you're going to have it as y into y minus 1 divided by 2. So n5 is nx5 times ny5. So now you can find out what is the value, which is y into y minus 1 divided by 2 into 1 minus x square. So this you can find it out as simple as that. So this is what we have seen, or this is what I have written it down. But here again, it is not 1 plus x square, it is 1 minus x square. So just note down that particular correction. So this is not plus, rather it is minus. So this particular value as a whole is 1 minus x square. So put together, now it is of the proper form, y by 2 into y minus 1 into 1 minus x square. So similarly for node 6, if you can try it out, it will be easy for us to get into the point directly. So in the x direction, as everyone is pretty clear with it, so our x direction, we'll have the term of 0 over here, so we'll have the term 0 over here and -1 over here, and then here we have a 1. So it is x minus 1, x minus 0 into x plus 1, which is minus of -1, and then just substitute the value of that particular x term, node 6, you will be able to find out the rest of the term. Similarly, in the y direction, again we'll have two terms to be considered. We are looking into the sixth node, so obviously you'll be ending up with the term 1 and -1. So you'll be having y minus 1, y minus of -1, which is y plus 1 over here. So now we can find out what is the value of your n6. Just multiply these two terms, we'll be getting into the answers directly. sorry. So similarly, you can find out the shape function for the other nodes. So here again in the x direction, if you are going to consider, we'll be having two terms that has to be considered. So in 7, x direction is over here, so we'll have the term of -1 to be considered over here and +1 to be considered over here. So you can substitute the values of -1, which is +1, and here again it is -1. So now we can just as stated in the previous steps, it is a minus b into, I'm sorry, it is a minus b into a plus b, or it is just a minus b the whole square. Similarly, in the y direction, if you do want to consider, again what you're looking is this particular direction, y direction. So you're going to have the term of 0 and -1. So you're going to end up as y minus 0 into y minus of -1, which is y plus 1, and n7 has a value of 1, so it is 1 minus 0 into 1 plus 1. Simplify it, we are going to get to the answer directly. So it is y into y plus 1 divided by 2, and then finally the shape function for node 7 can be found out when we multiply nx7 and ny7 as a whole. So now we have two other terms that are left behind, that is node number 8 and node number 9. So node number 8, again in the x direction, if you do consider, we are going to have 0 present over here and 1 that is present over here. So it's pretty simple for us to find out. So if we are in the x direction, we are going to have zeros which are present over here and 1 which is present over here. So it is x minus 0 and x minus 1. Then substitute the value of x which is present in that node 8. We'll be getting the value of nx8. Repeat it for the 8th node in the y direction. Again, we are going to end up with 1 minus y the whole square. As simple as that, we can find out the shape function for node 8. Repeat the procedure for node number 9. The same answers will be present over here. So finally, this particular step will allow you to find out the node shapes for all, the shape function for all the nodes that are present over there, starting from n1 till n9. Using the simple natural coordinate system and the Lagrange's method, we have found out the shape function for all the 9 nodes. And this particular, again repeating the same point, this is a higher order element, and we have used the Lagrangian method to find out the shape functions. Thank you.